Today, we're diving into the single biggest transformation the auto industry has seen in, well, a century. We're talking about a shift from a world of steel and hardware to a world that's all about software and data. And look, this isn't just a small step, it's a total teardown and rebuild of how we even think about, design, and build cars. But this whole shift, it creates a really interesting paradox.
To really get what's happening, you have to start with that question. How is it even possible that a brand new car, a machine that took years of engineering to create, is in some ways obsolete the second it's delivered to you? Well, the answer is that the car industry is basically running on two different clocks, and they're ticking at wildly different speeds.
And this slide right here, it just nails that clash of worlds. On one side, you have the old way, slow, deliberate, 4-year cycles all locked into the hardware. You bought a car, and that was it, a finished product. But the new way, it's all about being agile, iterative, and totally software-led. I mean, some brands are already pushing their development cycles to under 24 months. The car isn't a static thing anymore. It's a dynamic platform that's built from the ground up to evolve.
So this all leads us to a pretty crucial point. That traditional way of developing cars, it's not just slow, it's fundamentally broken. There's this huge and honestly growing gap between what car makers want to do and what their old-school processes can actually deliver. This chart is a brilliant way to see the crisis. Engineers call it the scissor chart, and you can see why. You've got one blade, which is software complexity and all the work needed to test it, and that is just skyrocketing. Then you've got the other blade, development time and budgets, which are constantly being squeezed tighter and tighter. These two blades are moving in opposite directions, and that big gap in the middle, that's where projects go off the rails, costs explode, and innovation just dies. So how in the world do you solve this? Well, the first step isn't about writing better code, surprisingly. It's about fundamentally rewiring the car's physical and electrical backbone. We literally have to redesign its brain and its entire nervous system to get it ready for the data age.
You see, the old way was this tangled mess of dozens, sometimes hundreds, of little individual computers called ECUs. The new approach, this zonal architecture you see here, is so much cleaner. Just think of it like a simplified, high-speed nervous system. Data from all the sensors, the car's eyes and ears, flows to these regional hubs called zonal controllers. Those hubs then shoot the important stuff to a powerful central computer, the brain. This isn't just tidier, it can cut the weight of all that wiring by over 30%, and crucially, it creates a standardized data highway that makes things like over-the-air updates way easier down the road.
Okay, so once you have that modern nervous system in place, now you can change where the development actually happens. And that brings us to the next massive strategy, moving the entire proving ground from the real world into the cloud. We're now at a point where we can build, test, and even break cars virtually, long before a single piece of metal gets stamped.
And the scale of this change is just staggering. The industry is aiming to do 85% of all its vehicle validation work in the virtual world. This is the heart of what's called the shift-left strategy. You're basically pulling all that testing and validation way earlier in the timeline by replacing super expensive, slow physical prototypes with these incredibly detailed digital twins.
Now, if you're a little skeptical about how realistic all this can be, just look at this stat. By using AI that's been trained on decades of real-world data, engineers can now predict the results of official, high-stakes crash tests with over 95% accuracy. Think about that. This isn't just a guess, it's predictive engineering at its absolute best. It saves millions of dollars, and more importantly, it helps save lives by designing safety in from the very beginning. All right, now for the next big shift, and this one might be the most revolutionary of all. So if the new architecture is the car's nervous system, and the cloud is its virtual test track, then the entire fleet of cars already on the road becomes the world's biggest, continuously running research lab. And the key piece of tech that unlocks this whole idea is called shadow mode. It's a genius concept. Imagine a new piece of self-driving software that's ready for testing. Instead of just putting it in a few prototypes, you deploy it silently to thousands, even millions of customer cars. The new software sees everything the driver sees, it thinks about what it would do, brake, steer, accelerate, but it never actually acts. It's like having an AI student driver in the car with you, silently learning from millions of miles of real-world human driving. So how does this actually help find the really tricky bugs? Well, first, the new software just runs silently in the background. It logs all its decisions, but again, doesn't do anything. The real magic happens at step 3. Whenever the AI's decision is different from what the human driver actually did, the system flags it. These divergence events, that's the gold dust. Those are the weird, unexpected, real-world scenarios, what engineers call edge cases.
And only these tiny but super valuable data packets are sent back to the cloud for engineers to analyze. Now, all this incredible technological change isn't happening in a bubble. Of course not. It's actually fueling a new, incredibly high-stakes global race for who will dominate the future of mobility. The competition isn't just about who can build the most cars anymore, it's about who can build the best data ecosystems and has the sharpest software talent.
And as you can see from this table, each major region is playing to its own unique strengths. You've got China, where their incredible control over the EV supply chain lets them develop and iterate at lightning speed. Then there's Europe, leaning on its deep history of engineering and safety to set global standards and ensure digital sovereignty through things like the ECVA initiative. And meanwhile, North America is leveraging its dominance in cloud computing and AI to really lead the charge on monetizing software and creating new data-driven services. Everyone's taking a different road, but they're all trying to win the exact same race.
So, when you boil it all down, the single biggest takeaway from all of this is a fundamental change in what a car is. It has stopped being a static, finished product that you buy off a lot. It is now a dynamic platform, a piece of high-performance hardware that is designed from day one to be constantly learning and evolving through software.
And that really leaves us with one final thought. The next time you sit in a brand new car, just think about all those invisible systems working away, the zonal architecture, the digital twin that it was born from, and the silent shadow modes that might be running in the background. And ask yourself this: are you just driving a machine? Or are you actually piloting a node in a vast, constantly learning network that is literally building the future of how we all move?